Assalamu alaikum. My name is Shakir and this is my video presentation for the topic MRI magnetic resonance imaging. Magnetic resonance image was discovered in 1947 by Felix Bloch and Edward Purcell. However, the first clinical image of MRI was obtained in 1977. So, how MRI works? Now we know that our body is composed of fats, proteins, other minerals, but it is mainly composed of 70% water. Now, what is made up of hydrogen atom, two hydrogen atom and one oxygen atom, and in hydrogen atom there is a proton, and we know that the proton has a specific dipole moment, which plays a very important role in this MRI, as it is a specific dipole moment, which means that it has its own north and south pole. So, when we apply external magnetic field, the proton aligns its align itself in according to the magnetic field. For example, if an electron is spinning and it's on its own axis, and when we apply the external field, it starts processing. So then it starts processing. Okay. So later on, then we send a radio frequency pulse, which then affects its movement again, and then we switch it off, and then it becomes a line again. So what happens is that in our body there are a lot of there is a lot of water and hydrogen atoms. So what we do is we put our body inside a magnetic field, and what happens is hydrogen atom align itself in the magnetic field, and they start processing in a specific frequency, which is known as the Larmor frequency. And then what happens is that we just put provide it with a radio frequency pulse to the region where we want to take the MRI. For example, if we want to take the MRI of the heart, we will provide it and we will strike it with the radio frequency pulse towards the heart, and it will just disturb the hydrogen atoms, and those will become out of phase again, and they will start processing out of phase. For example, they will not be in phase again, they will be out of phase again, and then after the radio frequency pulse is turned off, then after some time they will lose the energy and they will be in phase again. So this happens inside the MRI. So there are two type of contrast. There one is T1 contrast and the other one is T2 contrast. The T1 contrast is also known as the longitudinal relaxation or spin lattice relaxation, and it provides us with the bright side of the image. For example, when we strike the radio frequency pulse, and it disturbs the atoms, and they become out of phase. When the time taken by them to become in phase again, this is known as the T1 relaxation. And there is another contrast that is known as the T2 relaxation. This is also known as the transverse relaxation. What happened in this is that when we provide the radio frequency pulse to the atoms, they becomes out of phase. When it is the time taken by them to become out of phase, this is known as the T2 relaxation. So this is these a few things that we need to know about the MRI and how it works. Now, what will happen when we put the body in the magnetic field? Due to the Z-man effect, there will be the splitting of energy, and there will be high energy level and lower energy levels. Some of the electrons will be in the high energy level, and others will be in low energy level. And when we provide the radio frequency pulse, what it does is it will absorb the energy and they move to the high energy level. When the radio frequency pulse is turned off, they lose the energy and they again come back to the lower energy levels. So what happens in this case is due to the movement, there is the movement of charges, and which movement of change in magnetic field, there is also the uh, change in the electric field, which according to the um, Faraday's laws will produce the electromagnetic radiations, due to which the detailed images of the body are produced. And the NMRI can be used for in case of cancers, tumors, and for bone and brain scans, etc. Thank you.